In downtown Gaussville, there are 3 buildings with different heights: the Euclid, the Newton, and the Galileo. Only one of the statements below is true. The Newton is not the shortest, the Euclid is not the tallest. Sorry, the Newton is not the shortest, the Euclid is the tallest, the Galileo is not the tallest. Ordered from shortest to tallest, in height the buildings are. Well, we have to do a little bit of legwork here. So we got the shortest one, then we have the building that's sort of in the middle, and then the tallest one. So the hope is that the first scenario that we try works. If it doesn't, that's okay. We try another one. So let's try this scenario. Let's say this statement is true, and then these 2 are false. Let's see what happens. If the first statement is true, the Newton is not the shortest. Well, that means it's not the shortest, so it's not here. It's either here or here. I don't know which one, but it's one of those 2. It's either the middle one or the tallest one. The next statement, the Euclid is the tallest. Now, that's a false statement according to what I've labeled. The Euclid is the tallest is a false statement. So the Euclid is not the tallest. So the Euclid is either here or it's here. Next statement, the Galileo is not the tallest, is a false statement. So that means the Galileo is the tallest. So that means G here. Can this be combined? And the answer is yes. We can make the Euclid the shortest, we can make Newton the middle one, and we can make Galileo the tallest. If we do that, it becomes ENG from shortest to tallest, and that is the answer. So I got lucky on the very first try. I got it right. So number 22, the answer is C. Dolly, Molly, and Polly each can walk at 6 kilometers per hour. Their one motorcycle, which travels at 90 kilometers per hour, can accommodate at most 2 of them at once and cannot drive by itself. Let T hours be the time taken for all 3 of them to reach a point 135 kilometers away. Ignoring the time required to start, stop, or change directions, what is true about the smallest possible value of T? We have to develop a strategy to figure out what is the way that they're going to travel. And I think that is the most challenging part, figuring out the strategy. Once the strategy is figured out, then the math is relatively straightforward. So here is the strategy. So I'm going to draw a few lines and then explain it. So the 3 friends, D, M, and P, all obviously start off at the start, and this whole distance is 135 kilometers to, I guess, the finish line. We can call it finish. And the strategy is as follows. First, 2 of them, let's say Dolly and Molly, get on a motorbike, and they go all the way to a certain point. They get to here. So D and M arrive here. Meanwhile, Polly is walking. So Polly is not staying here. She's walking. So she's somewhere around here. Okay. Now, at this point, we don't know any of these distances. So I'm just going to label this distance X. It's the distance from that point to the finish. Now, this is a very important point. That is what you call a drop-off point. That is where Dolly drops off Molly. And then Molly starts to walk in this direction. So Molly will start walking toward the finish line. But then Dolly goes back to pick up Molly. Okay? So now Dolly's coming back. And by this point, Polly is walked till about here, right? And then Dolly comes back to pick her up. So this is now a pick-up point. Now the distance that Polly has walked from the start to there, I don't know, so I will call it Y. Okay? Meanwhile, Molly is still walking. She is probably pretty close to the finish line. Not sure where, but somewhere around there. Then Dolly picks up Polly and then drives her back on the motorbike. So then they all go back together, and eventually they end up at the finish line. So they all end up back at the finish line, P, D, and M. Okay? And they all arrive at the finish at the same time. So let's figure this out. And we're going to use, of course, that formula, speed is equal to distance over time, and any variation of this formula, such as time is equal to distance over speed. So let's figure this out. Let's call this first scenario T1, and then this second scenario we'll call T2, and then this final scenario we'll call T3. And then, of course, the T is the time taken for all three of them to reach point, I guess the finish line. So that T that they're asking about that's in the answer choices is really T1 plus T2 plus T3, because all of them have to reach the finish line. So here we go. What is T1? Well, it's distance over speed. And for this distance, it's from there to there. Now the whole distance is 135. And from here to here, I have labeled that as x. So that distance that the two friends on the motorbike travel from there to there is really just 135 minus x over 90, which is the speed. And then for Dolly, which is the first friend that I really am talking about, T2, her T2 is basically going from that drop-off point back to the pickup point, right? She was here, but then now she's traveling to there. So she goes back like that. So that distance is basically 135 minus x minus y. And again, over 90, because she's still on the bike. And then the last distance is when she goes from the pickup point, right here, all the way to the finish line, and ends up here. So that is going to be 135 minus y all over 90. All right. So I hope that makes sense. Those are the three times for Dolly. And the total, of course, we need to figure out. But the only way we could figure out the total is if we had actual numerical values for x and y. And we don't. So what do? Well, if we don't have that, we have to come up with new equations. We have to come up with additional equations that will allow us to figure out the values for x and y. And how we do that is by looking at the other friends. We'll look at Molly, and then we'll look at Polly. So in the very same way, let's look at Molly. What is her story? Well, Molly initially was on a motorbike until the drop-off point, so that's going to be 135 minus x over 90. Now let's talk about T2 for Molly. Interestingly, for Molly, T2 and T3 is sort of the same, because that whole time she's just walking. So we actually don't even need to worry about two different times. We should just concentrate on her second phase, which is just walking, and that's just x over 6. The distance is x and the speed is 6 because they're walking at 6. So that's all there is for her. And then Polly, her T1 is that initial phase where she's walking. So that's actually going to be just y over 6. And then her final phase is when she's on the motorbike and going all the way to the finish line with Dolly. And that is 135 minus y over 90. So there you go. This is a breakdown of all three friends. Now we still haven't figured out the numerical values for x and y, and that's obviously required. So how do we do that? Well, we do that by looking at the times and comparing them. So for example, after this drop-off point, the time it takes Molly to go from the drop-off point to the finish line is this right here, x over 6. But that is the same amount of time it takes Dolly to go all the way back to the pickup point and then back to the finish line. So remember, they all arrive at the same time. So that means this is equivalent to this plus this. Okay? That's very important to this question. So 135 minus x minus y plus 135 minus y. These are both over 90. is equivalent to x over 6. Those times are the same. And in a very similar way, we can compare Molly and Polly. Comparing Molly and Polly, their total times are the same. The time it takes Molly to be on the bike and then walking is basically her entire journey, is the same amount of time as the entire journey for Polly, which is an initial walk and then a motor ride. So that means that 135 minus x over 90 plus x over 6 is equivalent to y over 6 plus 135 minus y over 90. So there we go. We got two equations, two variables. We can now solve for x and y. So let's proceed, and then we can come back and figure out the time, which is right here. Well, this equation, let's start with that one first. Let's multiply through by 90. That will get rid of the fraction. So we have 135 minus x minus y plus 135 minus y. If you multiply this by 90, it becomes 15x. And then let's put everything on one side. 270 minus 16x minus 2y is 0. So if I isolate for y, I get 270 minus 16x. Divide through by 2, you get 135 minus 8x. Okay, let's solve this one right here. Divide or multiply through by 90 and you get 135 minus x plus 15x plus 15y. And that's going to be just 135 minus y. So the 135's cancel, and we got 14x is equal to 14y. So that means x is equal to y. Oh, okay, interesting. Substituting that back into here, and we got 135 minus 8x is equal to y, but y is equal to x. So that means 135 is equal to 9x, and therefore x is equal to 15. And that means y is equal to 15. Okay. There we go. I just got numerical values for x and y. Now I can figure out my times. So keeping this in mind, that t is equal to t1 plus t2 plus t3. Let's just use Dolly since Dolly has t1, t2, and t3. So that's going to be 135 minus x over 90. Well, x is 15, so that's going to be 120 over 90. T2 is this 135 minus x minus y. Well, x and y are both 15, so it's 135 minus 30, so 105 over 90. And then finally, this guy, 135 minus y, so that's 120 over 90, since y was 15. And that is, in terms of decimals, a 1.33 plus 1.166 plus 1.33, and if you add it all up, it's approximately 3.83. So that is the shortest. The strategy was to figure out the shortest, 3.83, and therefore t would lie in which interval? A, right here. So like I said, the strategy, which is this diagram right here, is the challenging part of the question. Once you get the strategy, then you just use this formula to figure out what is the smallest possible value for t, which is the time. Number 25, the answer is A. Two numbers a and b with a between 0 and 1 inclusive and b between 0 and 1 inclusive are chosen at random. The number c is defined by c is equal to 2a plus 2b. The numbers a, b, and c are each rounded to the nearest integer to give a, b, and c respectively. For example, if small a is 0.432 and b is equal to 0.5 and c is 1.864, and so big A is 0, big B is 1, and big C is 2. What is the probability that 2 big A plus 2 big B is equal to big C? This question, we will create a table and then we'll walk through it. And there is going to be, I believe, 4 by 4, which is 16 different scenarios. So here we go. Let's start filling this in. The first column is small a, then we have small b,
Then we have 2a plus 2b equals small c. And then we have big A, big B, 2 big A plus 2 big B, big C. And then we have, is 2a plus 2b equal to c? Yes or no? That's why I put a little question mark there. And for each of these, we'll calculate it. And the good news is that there's only 16. It's fairly lengthy, but it's not outrageous. And a lot of this, you'll see, has a little bit of a pattern too. So I'll just do a few of these, and then we'll kind of extrapolate it. So let's start off with this one. So A, our first range, is between 0 and a quarter. B, same thing. We'll start with 0 and a quarter, like that. And therefore 2a plus 2b, which is c, will be between 0 and a half. Now, big A is the closest integer, which is 0. B is the closest integer for small b, which is 0. 2a plus 2b obviously is 0. C, we have to now look at this range. Big C, we have to look at that, and that also equals 0. Is 2a equal to 2b? And the answer is yes. If it's a yes, I will put a number 1. And if it's a no, I'll put a 0. So let's go to the next one. Again, I'm going to use the same range for A, but now I'm going to move up for the range for B. This time we're moving up to a quarter and a half for those ranges. C, therefore, would this time be between a half and 3 over 2. Big A is going to be 0. Big B is 0. 2a plus 2b is 0. C, this time, is 1. 2a plus 2b, is it equal to c? No. So because it's no, I put a big 0 there. All right. Let's do a few more. If A is now going to be the same, but I'm going to go up to a little bit higher on the b's by a factor of a quarter. So this is going to be a half, and this is going to be 3 over 4. So now C, therefore, will be between 1 and 2 this time. And now big A is 0. But big B this time is 1. Therefore, 2a plus 2b is going to be 2. C is 2. Is 2a equal to c? 2a plus 2b equal to c? And the answer is yes, so I put a big 1 there. All right? So I hope you get the hang of that. We'll do one more, and then I'll fill them all in, because I don't think you want to listen to me talk you through 16 of these. So we'll go up to the next one, which is 3/4 is less than b, and b is less than 1. C, therefore, is going to be this time between 3 over 2 and 5 over 2. So A is again 0, but this time B is 1. 2a plus 2b is 2. C is 2. Is 2a plus 2b equal to c? The answer is yes, and therefore I put a nice 1 there. Okay, so I'll just fill them all in, and then we'll talk about this column, which will help us figure out the probability. And there you go. That entire table, I filled it out and made this a work of art, or at least I'd like to think so. Now, of course, we have to look at this column of the table and see, first of all, how many do we have? How many scenarios? We have 16 of them. So that probability is going to be something over 16. And the question is, does 2a plus 2b equal c? Does 2 big A plus 2 big B equal big C? Yes, only a few times. Once, twice, 3, 4, 5, 6, 7. 7 times it equals 2a plus 2b equals c out of the 16. So this is the probability for the question, 7 over 16. I encourage you to make this table, understand the table, and you'll see that it's a repeating sort of pattern, and it's actually not so bad. It's not difficult, it's just very time consuming, considering that on a math contest you have a very limited amount of time. 7 over 16 is the answer to number 25, and that would be choice D. Kathy owns more cats than Alice and more dogs than Bruce. Alice owns more dogs than Kathy and fewer cats than Bruce. Which of the following statements must be true? Let's write this out. So the amount of dogs that Kathy has, I'll call that KC, is greater than the amount of cats that Alice has. Completely according to the question stem. I'm not adding anything new. And then they're comparing Kathy with Bruce. And they're saying that the amount of the amount of dogs that Kathy has is more than the amount of dogs that Bruce has. So this is the first part. The next sentence talks about Alice. Alice owns more dogs than Kathy, okay? And then fewer cats than Bruce. So fewer cats than Bruce. Okay, so this is basically the inequalities based entirely on the question stem. So we got to combine them, right? Okay, so the dogs, I think I can. KD goes in the middle, and Alice is greater. And who's less? Bruce, right? Okay. And for the cats, unfortunately, there isn't a perfect sort of continuum because both Kathy and Bruce have more cats. So we don't know between Kathy and Bruce who's got more. Okay, let's go through the answer choices. Bruce owns the fewest cats. Well, that can't be true because he has more cats than Alice. That's out. Bruce owns the most cats. We don't know that for sure. We know he owns more cats than Alice, but we don't know how he compares with Kathy. So that is not something we can be confident about. Kathy owns the most cats. She owns actually the least cats. Alice owns the most dogs. The answer is yeah. She does. And let's just finish it out. Kathy owns the fewest dogs. She owns the middle. I guess in the ranking, she's in the middle. So of the answer choices, the one that must be true is D for number 21. 5 consecutive positive integers have the property that the sum of the second, third, and fourth is a perfect square, while the sum of all 5 is a perfect cube. If m is the third of these 5 integers, then the minimum possible value of m satisfies. X plus 1, x plus 2, x plus 3, and x plus 4 represent our 5 consecutive positive integers. And they tell me that the sum of the second, third, and fourth is a perfect square. So the second, third, and fourth, when you add them up, they are a perfect square. So I'll call that n squared. So this looks like 3x plus 6 is n squared. And I can factor out the 3 and I get x plus 2 is equal to n squared. All right, now let's look at the next sentence. The sum of all 5 is a perfect cube. So x plus 1, all of those is a perfect cube. So I'll call that p to the power of 3. And when you add all this up, it becomes 5x plus 10 is equal to p cubed. Factor out of 5 and we get x plus 2 is equal to p to the power of 3. So that's just the initial setup of the question. Now they're telling me that m is the third of the 5 integers. So the third of the 5 integers is this right here, and they're saying that is equal to m. Okay? Well, interestingly, that is right here and right there. So instead of x plus 2, I can put in the letter m. So that becomes 3m is equal to n squared, and this becomes 5m is equal to p cubed. All right, so where do we go from here? This is about the end of the road for us, right? With regard to the question stem. From this point on, we have to figure out what to do. So what do I do here? Do I take the square root? Do I take the cube root? Do I subtract? Do I add? Factor? Well, the best way to approach this is to just look at it from the perspective
of the fact that 3 times m must be a perfect square. So, for example, if m was 3, then it would be 3 times 3, and that is indeed a perfect square. So that works. But does it work over here? Well, let's see. If m is 3, this becomes 5 times 3, which is equal to p to the power of 3, and that's 15, and 15 is not a perfect cube. So you see what I mean? We have to experiment with values of m. But we don't have to experiment too long because there is a system you can use. The first thing, of course, is to recognize that 3 times something is going to be a perfect square. So I'll put that m on top like that. Now, in order to get a perfect square, m has to have at least a 3 in it in terms of the factors of m. That's the only way. And then the rest of m, we don't know yet. But there's got to be at least a 3 in there because this 3 has to have a matching 3 for it to be a perfect square. Okay, so far so good. The exact same kind of thinking over on this side. P to the power of 3. And I'll put the m on top. Now, I've already got a 3. M has to have a 3 in there. So far so good. But this 5 tells me that there also has to be 2 5s. Like that. That's the only way we're going to get a perfect cube. 5 has to have 2 more 5s to become 5 to the power of 3. All right? Now, with the same thinking, the same logic, there has to be 2 more 3s. That's the only way 3 can become a perfect cube. If there's 3 of them, it would become 3 to the power of 3. So there you go. That is what m is. I'll put that over here. 3 times 5 times 5 times 3 times 3. Now, of course, m could be other things as well, but they want you to figure out the minimum possible value of m. So this is the minimum possible value. And if we multiply this out, we get 3 times 5 times 5 times 3 times 3, which is equal to 675. So that is the minimum possible value of m, and therefore that is going to be between 600 and 800. So the answer to number 21 is D.